Good morning, everyone, and welcome to today's webinar, which is on managing energy costs in food and drink. A big thank you to our professional affiliate members, Enel X and Powerstar, who'll be sharing their insights with you in today's session. There will be a Q&A at the end, so please put any questions that you have into the Q&A tab on the panel, and we'll do our best to go through as many as we can at the end of the webinar. Following the webinar, we'll be sending you an aftercare email in the next couple of working days, and this will contain a recording of the webinar, a copy of the slides, and the contact details of today's presenters. So without any further ado, I'll hand you over to our first presenter today from Powerstar, James Hampshire.
Good morning, everyone, and thank you again for the time you set aside to listen to myself and my co-presenter Jamie ramble on this morning. So we want to take you through something that we find is particularly important and particularly pressing within the food and drink industry. From all the work that both of us have been doing over the many years that we've been operating, and the food and drink industry is one of the most energy intensive industries that you can find out there to this day. And we haven't, we struggle to come across anything that really beats what the intensive processes that are required for the industry that we're in. So we're going to go through 6 things at a fairly high level and a fairly rapid pace. Like Luke said, we've got 20 minutes of presentation and 10 minutes of Q&A at the end. So hopefully we can get through most of your questions. But the main points that we're going to get through is, well, what's changing? What's happening? Why is the energy price increasing that we're seeing? Geopolitics is all hitting the bottom line of our businesses, but also at home on our energy prices. Then we're going to see where that sits on the P&L, and then start building together the case of your energy independence. So by trying as best we can to relief or bring some relief from the increases of costs that we're seeing from the grid. We're going to see how this looks, what it actually looks like on site, what technologies we can use, and how everything integrates on site. The next step, and then, like I say, we'll get some Q&A and some questions out, and we'll hopefully give some answers. So let's start cracking. Like I said, there's 2 of us here today. There's myself, James from Powerstar. Powerstar, we're a company based in Sheffield in the United Kingdom, and we are responsible for voltage optimization, low loss, ultra low loss transformers, and battery energy storage systems. And we handle the integration as turnkey projects for any form of energy saving, power resilience, or power quality is a real big key in this industry today. And we do lots of work within this industry. We do a lot of work with the tier 1s and tier 2s, and then a lot of the retail outlets as well. And then joining me today is Jamie.
Thanks, James. Hi, morning, everyone. Jamie Story from Enel X. I'll be speaking a lot more later on, but just as a very brief introduction to Enel X, we're a global energy business in the UK and Ireland. We act as an optimizer and aggregator of flexible energy. So our role in what we're talking about today is we partner with Powerstar to provide the financial element, the revenue element to the technical solutions that Powerstar provide. Thanks.
Thank you, Jamie. So what's happening? Why has it changed? So these 3 sort of pillars that we call, we in Powerstar, we have a lovely marketing team. We call this a trilemma, or the energy trilemma that we see here in this day and age. But one of the things that a lot of us here have been challenged with and being asked to do is reduce our carbon emissions, reduce the reliance on gas, and ultimately electrify as best as we can. And that obviously comes with quite the challenge, not only in the hardware and the infrastructure costs that we have, but then it typically ends up running more expensive when we start looking at the cost of the energy prices and the fluctuations that we keep seeing. Over the last 7 years, we have seen price increases like no one's ever seen before. And this again comes down to mainly geopolitics in sort of the past 12 months is what we're seeing. The UK is one of the last countries in the world to track its energy prices based on the cost, on the unit cost of gas. So as geopolitics, begins to reap havoc on them sort of supply lines or trade routes, our energy prices ultimately go up, regardless of how much renewables is in the network at any one period of time. We've got the heat wave on the go at the moment. You can only imagine how much solar energy we've produced over the past few days. We then start having a look at the cost of energy infrastructure on site. So to be able to electrify, to be able to reap some of the benefits that we see from electrification, it's quite an expensive game to play in. Local infrastructure on site is usually the smallest piece to the puzzle. The grid that we all rely on outside of this is aging and struggling. We expect, or there is an expected £40 billion a year required of investment into the national grid, into the transmission network, mainly into the distribution network, to make sure that we can meet the targets and change that's required. So these sort of things that you see here are all what are increasing and challenging us with the increase of energy prices today. So this is probably something that looks a little bit more familiar to a lot of people here. This is where the energy sits. So just taking out the impacts on the right hand side. Again, most of you are going to be familiar with this. 20% increase in energy per spike. It never really comes back down again. We never really see go back down to where it was before that spike. Once it's up there, it's up there. It might reduce some more, but it's always climbing. And then it ends up being 4 to 7% on the bottom line. And again, everybody's already on thin margins. We're already beaten down to try and be the most cost-effective product on the market. And energy being the second biggest operational expense, variability and shock pricing is a real impact to where we all sit. So, how do we do this? One of the things, among various options we have here at Powerstar, but one of the biggest benefits that we can see being deployed throughout the food and beverage industry is a battery energy storage system. So a lot of people sit there and go, "Oh, batteries, they're too expensive," and we'll get onto that part at the moment. But as you can see on the left-hand side, there's a lot of the things that I've spoke about already: geopolitics, energy price set by the gas market. You're at the mercy of a grid that's already at capacity, of a grid that's very much aging. And then we can sort of control costs through PPAs and CPAs as we move forwards, but they're still at the rate or the variance of market rates. So we are still quite exposed. So what Powerstar recommend and what we see a lot of benefit in doing on customer sites is deploying a battery energy storage system onto the site. Now, there's various benefits for this. If anyone was here on one of my previous webinars with the FDF, you can see what we can sort of do to layer up, these revenue packages that we can, these cost saving packages to be able to make this best fall within a reasonable ROI. But not only is the renewable firming and the storing the energy at peak times, buying and hedging your bets of energy up front, or using it as peak buffer or peak shaving, we're removing that reliance. We take into a more independent state of being able to use your own energy when you want to use your energy at your own costs, and being able to make sure that you're not fully exposed to the challenges that we see with the aging grid and the geopolitics today. So I think you're going to see this slide a second time, and this is a lot of, I get this day in, day out. Everybody has a look at a battery energy storage system, and they do the simple maths. They do, how much energy can I use off my existing renewables, or how much can I charge at night and then discharge throughout the day, and just do a night rate versus a day rate. In general, just doing them two things alone with a battery doesn't necessarily pay off. Certainly in the food and drink industry, we already find a lot of PPAs and CPAs where there is a lower pence per kilowatt in this industry. So battery alone, just doing the economy 7 trading rate, as everyone calls me, that reduced night tariff and discharging through the day, and doing renewable firming alone doesn't really pay back. We see about £40,000 a year or £39,000 a year of average savings. So you get quite a high payback. Now, this is where Jamie comes in, and the fantastic work that the team at Enel X do, and why we partnered with Enel X, is that we can actually reduce that payback to 25% of what we was expecting, by having all the same benefits of you owning the battery and you having the battery on site and doing all the peak shaving, all the buffering, everything that you need to do on site to make sure that you are just as independent from the grid, and then working with Enel X and trading your energy and working with the national grid much more intelligently is a solution. So I think now I've rambled on about the challenge and the hardware. I'll hand this over to Jamie to talk a little bit more about how we can achieve these cost savings.
Great. Thanks, James. Thank you very much. So as I mentioned earlier, we're an optimizer and an aggregator of flexible electricity. So essentially the role that we take here is that we take the flexible volume that this battery creates for you, that it allows you to have. We essentially trade that. But we don't necessarily trade the energy as in buying or selling. What we are really doing is trading the power, and we are serving that power into various markets, services and programs that are administered by NESO, the system operator, to serve some form of need that they have on the grid, to solve some kind of problem. So essentially what it comes down to, it's charging and discharging the battery, because that is really all it can do, but it's about doing it at the right time for the right reason to earn the maximum revenue. So as you can see here, the simple charge cheaply, finding the opportunities when electricity is at a lower rate, finding the dynamism or variability that's built into your supply contract, or maybe looking outside of your supply contract, but also performing different grid services. Step 3, I'll just touch on for a second in terms of grid resilience, very timely given what happened yesterday on the grid. There was actually quite a lot of activity and the grid was extremely stressed. So there were several frequency calls yesterday. We got close to potentially receiving a capacity market notification. The reason for that, it's a combination of weather and geopolitical issues across Europe. When we have this heat wave event going across most of Europe, interconnectors are stressed. France has had to lower nuclear capacity. We've had very low wind, very high solar, but also really massively increased cooling demand throughout the country. All of these things add up to create these issues on the grid, these problems that NESO has to solve. Now, normally they would be a problem for us as energy consumers, but when you have a battery, they become opportunities to earn revenue. Just a little bit in terms of how we work now. As I go through maybe the next slide, participating in flexibility services and programs can seem quite daunting, and it can seem very complex. You have to bid in, you have to bid out, you have to register, you have to pre-qualify, you have to secure certain positions several years in advance. Our role in this whole process is to take that complexity away from you and to mitigate the risk of you participating in these markets. There are no fixed costs, there's no upfront fees, you're never out of pocket working with us or any optimizer. We work on a revenue share basis. So we only make money if you make money, and we're incentivized to make sure that you achieve the maximum revenue from these assets. And James said it very well, but the food and drink sector is very, very exposed to a lot of these issues. We already work with a number of key players within that sector, and several ongoing conversations with others at the moment. I'll briefly touch on some of these programs. Really what these are the sort of top line programs of which each has subsets and different nuances to it. I mentioned frequency on the market earlier. I mentioned there were frequency issues. How does a battery solve that? It either charges or discharges within a very short frame of time to help the grid for maybe 30 minutes, maybe an hour. Depending on how serious the problem is, you can get paid quite well for doing that and providing that service. I think it's most useful to think of all of these as levers that National Grid or NESO can pull in the event of a problem. Which lever they will pull depends on how big the problem is. I briefly mentioned capacity market. That's the very last lever. That's the last bullet in the chamber to try and solve any major brownouts or tipping over of the grid. That's the one that we've never had to use. Fortunately, all these other programs and services are used pretty regularly. Sorry, I should add, it's actually possible to participate in all of these services without a battery, theoretically. But what that would require is for you to actually change your way of working. It would require you to alter a production schedule or actually switch something off or turn something up. The beauty of the battery is you can participate in all of these programs and services and your production schedule will never know, because the BES acts as the buffer. It's the asset that is providing the response and production can carry on as normal. I've put this up here just as a very plain example of what a typical site setup might be. And I also wanted just to talk about some of the considerations that we take into account of the site configuration. So factors that are really important include the import and export capacity of the site, the size of the battery, the state of charge requirements, the depth of discharge requirements, the specification of any distributed energy assets, so your solar, how much are you self-consuming, how much are you exporting, how much is curtailed, how much value can be captured from there. There's probably an important point here because it's something we discuss with clients regularly, that what we do in terms of program participation or service response, it's easier to think about that. That's what we do with the battery when it's not charging from solar or it's not doing the most obvious thing. So when James did that payback example earlier, you charge whatever excess solar you have into the battery. That's a given. You maybe only have that excess solar for 3 or 4 months of the year, only on certain days, only at certain times. For a battery to work and have a good ROI, you need to sweat the asset. It needs to be cycling daily. It needs to constantly be churning. All these other programs and services is how we make that happen. There's a point here around the supply contract or the supplier rate. That's a really important thing for us to understand, because the value that can be added isn't always about the commodity. Very often it's about the non-commodity, particularly depending on which DNO region or DSO region you're in. There can be some really good earning potential in things like JUOS and CHNUOS spreads. So whenever we look at these projects for clients, that's something that we look to understand in a lot of detail, because there's probably more dynamism within your supply contract than you first realise. Moving on then, just conscious of time, so I'll keep moving to try and get to some questions. This is a revenue example based on the site setup that I showed previously. So there's a few numbers to take into account here. We generally run a 15-year revenue model, which is the 4.39 million number. So that is the value we expect this battery to add to the site over the course of 15 years. The pie chart is a breakdown of the year one value and where that comes from. And I think there's an important point here about wholesale trading, because as you can see, that's the single most valuable service that we're participating in. And several of you may think, well, we're in a fixed supply contract, or we have a long-term hedged contract. We can't really participate in the wholesale market. So this is exactly the sort of situation where we come in as a virtual trading party, where we can actually take the charging and discharging of the battery. We can treat them as deviations to a baseline, and we can enter them or trade them into the wholesale market. So it kind of gives you the best of both worlds. You get to maintain your safe, secure, stable, long-term supply contract, but also gives you a level of exposure to the wholesale market when the conditions make sense to do so, and give you that additional revenue. The other more chunky element there is the capacity market, which is, as I said, it's the last line in defence. It's the biggest lever we can pull. These are availability payments. If you're considering flex market access of any way, shape or form, it's really important that you ask what sort of capacity market position you're getting, whether it's a T-1 or a T-4. Some optimizers can only offer T-1, which for the 26-27 year is worth about £5,000 a megawatt, whereas we have volumes at T-4, which in the same year is worth £63,000 a megawatt. So that things like that, long-term optimization and market access strategy can have a very significant impact on the revenue that your battery can earn. These are just some more examples of different sites that we have modelled with Powerstar over time. And I think we've tried to be pretty upfront here, because I think what we don't want to tell you is that every site works with a battery and that every scenario is perfect. These values that you see on the right-hand side are the average pound per megawatt per year, that the value that the battery adds. So I would certainly say that the top three will return a good investment. They will provide a good payback on that asset. The fourth in line, it may be a little bit marginal, and there may be some reconsideration required of the project. The bottom two, I would say, almost certainly going to require some element of redesign. And largely that comes, I think James would hopefully agree, when the batteries maybe not being sized right first time. If we go back to those projects, which we have done with all of them, and we look at a more right-sized asset, then we get those pound per megawatt numbers up, and we start to arrive at a much more attractive return on investment. So this is just one of the ways that we work in step with Powerstar to make sure that the solution we put in front of the client meets their needs. So yeah, just going back to this slide quickly that James showed you earlier, hopefully that's given you a bit of an overview of the way in which we can add value to the sort of technical value and expertise that Powerstar can add to your projects, and how we work together to produce a sort of complete solution. What I would say is, if you have looked at a battery without considering optimization revenue, then you've missed a step. And vice versa, if you've looked into the different ways that you can participate in flex without thinking about having a battery, you've potentially missed a step. The two work very well together. So one conversation could have a very big impact on your energy cost forever. I think there was a point in one of James's slide earlier that is really worth pulling out. It's not a matter of whether there will be another major catastrophe or another major event which will impact on energy prices. The question is how well prepared you're going to be for that, how well you can mitigate it. James, is there anything you'd like to add to that slide there?
No, I think, Jeremy, I think you summed that up really, really well. I think from sort of the view of Powerstar, we come as a turnkey solution provider. A lot of what we've talked about here, we've tried to keep it as high level as possible and try and remove a lot of the complexity out of it, and trying to make sure that we can articulate it without putting all the jargon in there and putting all the complex challenges in. The partnership that Powerstar and Enel X, we have, and we work together to take that complexity, to take that barrier to entry away. To make sure that you understand what the system is doing and operating, having total visibility and transparency of the asset and also the energy on site, but then also working with Enel X and bringing that revenue stream and being able to commercialize the battery and make the paybacks look a lot more appealing. This partnership isn't particularly common in this industry and in this game. So if there is anything that we can do to help you out, you've got Jamie's contact in the bottom right, and then my colleague Alexandra in the bottom left.
Lovely. Well, thank you very much, guys, for presenting. Remind us to please put any questions in if you have got any. We've had a couple in so far, so I'll start going through them, but please do keep putting them in as we go along. The first question we've had is, we've looked at batteries and the paybacks aren't great. What would you suggest?
Hopefully we maybe covered that a couple of slides ago, but if the payback's not right, I would say there's one of two things wrong. The battery solution that has been proposed to you is possibly not been quite right, and there's potentially been gaps there or ways that it can be improved, or potentially the revenue strategy has not been 100% right. We work closely with Powerstar. We also work with others where we know what paybacks can be achieved. We know that good positive return on investments can be achieved with the right technology and with the right revenue strategy. So I would say if you looked at it a year ago, James knows this better than I do, but pricing within the battery market's quite dynamic and it's on a downward trend. So paybacks are improving all the time.
Yeah. And I think just to echo Jamie's point as well at the start is making sure that the solution has been tailored right for you. The amount of clients that we work with that say, "Oh, but my solar installer put this size battery on because it matches the PV." Our battery sizing starts with your half-hourly data. It doesn't start with a site visit. It starts with an analysis of data of what is your load doing, what is your PV, or if you don't have any renewables, what is your load doing, and how can we flex that against your import limit, your export limit, whatever the constraints are we have on site. That's where it starts, not based on an existing asset.
Awesome. Thank you very much, both. The next question which we had in is from somebody who leases their site, and they've asked, if we were to move in 5 years, could we take the battery with us?
So absolutely, it's just like moving any other piece of machinery. You own the asset, as long as you don't finance it with anybody else or do anything like that. But as a capex purchase from Powerstar, you own the asset, and if you was to move, Powerstar will be there to do that for you and move that piece of kit for you. So that's really not a problem. We just have to be mindful and brought along the journey of any other considerations when we move to your new site. Is there a different power supply? Are we connecting to a different voltage stream? Are we, is there any limitations that are going to, inhibit the performance of the system from a hardware point of view?
Thank you. The next question we've had, it's a bit of a longer one, so please do bear with whilst I read it out. But is there recommended cost-effective hardware providers for the solar panels and batteries? Direct purchase from China appears to be by far the most cost-effective. Are there any Chinese suppliers you'd recommend? Once set up, would you be able to manage / optimize trading around any installed hardware system?
So strongly recommend working with people like Powerstar as a supplier, and reputable UK-based companies. I think a consideration that a lot of C&I businesses in particular don't take into account is the installation and the design element associated with these projects. They see the commodity cost of buying a battery asset off the shelf from China and shipping it over and it landing on site. You need someone, firstly, you need to know that that's the right technical solution for your circumstances. You then need someone to install it. You need someone to maintain it. You need to be able to communicate properly with the manufacturer for any ongoing support. From an integration and an access point of view, one of the main reasons we choose to partner with people like Powerstar is that there are integration considerations that we have that make our lives a lot simpler in terms of working with people like Powerstar. So and we've seen several cases where people have bought cheap Chinese manufactured batteries straight from the supplier, and they've turned out to be very, very expensive projects in the long run.
Yeah, I think just to echo that a little bit of what Jamie said as well. If you look at the supply chain for batteries, and you can look at the UK, there's no battery manufacturer in the UK. There's no one makes the cell, so a lot of the supply chain starts out in moving east, and again we find this, and we come across this a lot. The hardware isn't necessarily sort of the biggest cost or the biggest challenge or concern. It is that integration piece. So what you can't do, and like Jamie says, is a battery stores energy. That's all it does, and an inverter will convert DC to AC and AC to DC, but it has to be controlled correctly, and it has to be controlled in the right way. To some very tight grid regulations and install regulations here in the UK. So yeah, from the install point, that's probably the easiest point. You follow British Standard 7671, it's a wiring regulation. But when we start looking at integration of batteries into private networks, the conversations that we have to start having with the DNOs, the conversations that we have to start having with the transmission network operators, if we're connecting up to 11 kV, 132 kV is a lot of where we see these battery systems. Actually, the UK grid is set up in such a fashion that you can't just put, or sorry, it's not you can't, it's you can't easily import a Chinese battery, for example, and just connect onto the grid. There is a lot of integration work, a lot of control work that we have to do around the grid and the ENA applications that need to be put in place. So while yes, it seems appealing because the power per kilowatt hour might be so much lower, actually by the time the project comes online, or you get the support that you need, because again, China and the guys out there are very good at making product. They have very, very almost no idea about how the integration works into a UK grid. You will end up paying more in the long run than you would going to a UK integrator, whether that's Powerstar or somebody else.
Lovely. Well, thank you very much, both. We've probably got time to squeeze in one more question, or more of a statement. So looking forward to hearing what you guys have to say about it. But somebody said, our organisation is reluctant to invest in new assets, given the global and local political instability. What would you guys say to that?
I would argue that when you have a battery, instability and volatility is good, because it creates opportunity for the battery to earn revenue. We're always going to have instability and volatility. Having the right assets on site is what's going to protect you from that.
And I think as well, by having the battery, not only does it increase the opportunities for the team at Enel, but having the battery reduces your exposure to a lot of the geopolitical risk of energy. It's there to protect you from them exact challenges, or help to protect you from the exact challenges that the finance teams or the operational teams are concerned about. the battery is not only going to help with the revenue from Enel X, is there to protect from a resilience piece or an energy cost piece.
There is also an element that capital investment's not necessarily required. They're similar to the solar PV market, and then PPAs came in, private wire PPAs, as the C&I BESS market is growing and expanding rapidly. There are new options coming available in terms of how those are funded and financed. So capital investment's not, a lack of capital investment is not necessarily a barrier to you having a battery on site.
Thank you very much. Well, thanks, James and Jamie, for the presentation. We've not got any other questions in there. A reminder again, it'll be sending across their contact details along with a copy of the recording and the slides afterwards if you'd like to share that with any of your colleagues at all. But yeah, unless there's any closing remarks from either of you, should we shut things down there?
All good.
All good with me.
Perfect. Well, thank you very much, everyone. See you later.
Thank you. Thanks. Bye-bye.